Hi everyone, this is Miss Strauss again, and we are going to be doing 10.6b today. We're going to be working on multiplying functions. So for the warm-up, I want you guys to find f plus g of x as well as f minus g of x. So go ahead, pause the video, take a minute, work those out, and then we'll do them together. All right, so for f plus g of x, we take f of x, so 4x squared minus 3, and we're going to add negative x squared plus x minus 1, and then we're just going to combine our like terms. So for x squareds, we have 4x squared, and then we have a negative x squared, so that becomes 3x squared. We only have one x term, so we just keep that the same, plus x. And then our constant terms, we have minus 3 and minus 1, so that becomes minus 4. So that's f plus g of x. For f minus g of x, we do the same thing, except we have a minus between our functions. And then remember, we have to distribute that negative sign to each term inside g of x. So each term has to change its sign. So rewriting this, we have 4x squared minus 3, and then we have minus a negative, so this becomes plus x squared, minus a positive, so that stays negative x, and then minus a negative again becomes plus 1. So f minus g of x is equal to, that would be 5x squared, and then minus x, minus 1, or minus 3 plus 1 gives us minus 2. So that's f minus g of x. So now we are going to be moving on to multiplication. Instead of just adding and subtracting functions, we're going to be multiplying functions together. So for our first example, just like yesterday, we have f of x and g of x, and we want to find what f of x times g of x is. So to do that, we do our f of x function right here, and we multiply that by our g of x function. And then we write that, just like how we had yesterday, f plus g or f minus g inside the parentheses. Now we have f times g of x is equal to, and luckily this is just like foiling that you guys have done before for these examples. So for our first one, we take 9x times x, which gives us 9x squared. So that's our first terms. Our outer terms, we have 9x times 5, which gives us 45x. Our next terms, we have, or our inner terms, I'm sorry, we have 20 times x, which gives us 20x. And then for our last terms, we have 20 times 5, which gives us 100. So we can simplify this down. We can combine those middle terms. So we have 9x squared plus 65x plus 100. So that's what f times g of x is. So what does this look like? So here we have our blue line is our f of x, 9x plus 20, and then our green line is x plus 5. So you'll notice that those are both linear terms. When we multiply those together, however, we get our quadratic term, which we found on the second pair on the page before this was 9x squared plus 65x plus 100. So now we get into the fun part. Now we get to talk about domain and range, which I know you all love so much. So for our domain of f and g, both of these are linear. So if we go back and look at the blue line and the green line, if we're looking for domain, you'll remember those are our x values. So that's our furthest left and our furthest right. And remember, lines extend forever in the positive and negative x direction. So we write our domain as negative infinity to infinity, and same thing for g, negative infinity to infinity. And while we're looking at domain, let's look at the domain of the product. So for our product, we have our red parabola here. And remember, since domain is the x values, all of our parabolas, their domain is all real numbers as well, because you can put any x value into a parabola, into a quadratic. So the domain of our product is also negative infinity to infinity. Now we look at the range. So remember, range is your y values, all your potential y values, your lowest point to your highest point. Again, with f and g, since we have lines, our lowest and highest points are going to be the infinities because we extend forever in the positive and negative y direction. So our range of f is negative infinity to infinity, and then our range of g is negative infinity to infinity. Now the range of the product. Remember, when we have a parabola, our product isn't all real numbers because we have a lowest point here. So our lowest point here occurs at our x value of negative 3.6, but our actual range, our y value, is negative 17. I'm going to round that to negative 17.4. So our y values can be anything above this line of y equals negative 17.4. So for our range, we can write that, since we include that point, negative 17.4, and then we go off to infinity. And if Pearson is asking you to write it as an inequality instead of interval notation, you would write y is greater than or equal to negative 17.4. So that is multiplication with domain and range. So when we have polynomials like this, it's nice and easy, just like our FOILing, just like our distributing, all things that you've seen before. But we're going to make it a little bit trickier for you. So before I walk you guys through these, I want you to give them a try, see what you come up with, and then I'll help you out with them. So pause the video, give these a shot. All right, for our first one, we are taking f of x times g of x. So our f of x function is the square root of x, and then our g of x function is 2x minus 1. So you'll notice here that this is a square root. This isn't a polynomial. So what do? Well, we do the same thing that we've been doing. We distribute that in. So by distributing that in, we have the square root of x times 2x minus the square root of x times 1, which is just the square minus the square root of x. You cannot combine the square root of x with 2x, okay? You can't put anything underneath this radical. You can't take anything out of the radical. So this is as simple as your answer gets. And you can just leave it just like that. Now, for h times k, our h of x function is our nice quadratic that we're so familiar with and that we love so much. So we have 3x squared plus 4. And then we're multiplying that by an exponential function, so by 2x. So same thing that we did up here with our square root function, we're just going to multiply that into each term. So our first term is going to be 3x squared times 2 to the x plus 4 times 2 to the x. This is as simple as this one gets. You cannot combine this 2 and this 3, and you cannot combine these exponents. You cannot combine 4 and 2. Okay? You have to remember that PEMDAS, exponentials, comes before multiplication. So since we can't simplify these exponentials anymore, we can't move on to multiplication. So this is as simple as your answer gets. All right, one more example. This one has polynomials, but the FOILing process is a little bit trickier. Give this one a try, pause the video, and then we'll work through it together. All right, f of x, what is the product of f of x and g of x? So that's what we've been doing this whole lesson, is we take f times g of x, and that's equal to, we take our f of x function, 5x squared plus 3x plus 4, and then we're going to multiply that by negative x squared plus 8. We have the same process when we have 3 terms here as we do 2 terms. So each term needs to multiply by each term. So first we take our 5x squared, we multiply that by negative x squared, so that gives us negative 5 x to the 4th. Next we take this first term, 5x squared, times positive 8, which gives us 40 x squared. Now we've multiplied 5x squared by both terms in here, we move on to 3x. So we have 3x times negative x squared, so that becomes negative 3x cubed, because when we're multiplying x's together, we add their exponents. So we have minus 3x cubed, and then we have 3x times 8, which gives us 24x, and now we move on to multiplying this 4 by both terms. So 4 times negative x squared, negative 4x squared, and then 4 times 8, which gives us 32. Now, there's only 2 terms in here that we can combine, and those are our x squared terms. So rewriting this, we have 5x to the 4th, and typically we want to write with the highest power going first and then descend through there. So next I'm going to write my cubic term, so minus 3x to the 3rd. We combine our quadratic terms, so 40x squared minus 4x squared gives us 36x squared plus 24x plus 32. So you'll notice here that we have a quadratic here and a quadratic here. Our highest power is 2 and our highest power is 2, and then our highest power here is going to be 4. So when we have 2 quadratics, the highest power is going to be 4. When we are multiplying things together, your highest power is going to change. So this is the notes that I took for this section. Gets cut off just a little bit, but this is the gist of it. I just have examples for each one of these and little notes about domain and range and just basically what you should do when you approach these problems. So take a minute, copy that down, and work through your Pearson. And that's it for 10.6.